So hello students, welcome once again. Just in the previous video, we saw the displacement or distance time graph. Since it is one-dimensional motion takes place in straight line. So now we will see, as I told, that is velocity time graph. Okay. Now from velocity time graph, what can we get? From displacement and or displacement time graph, we can get velocity. But from velocity time graph, we can get both displacement or distance and acceleration. Why? Now, since velocity equals to displacement or distance, since it is direction is not changing, so that's why velocity is equal to distance or displacement by time. So displacement is equal to multiplying velocity into time, we can get displacement. So this is displacement. Number 2 is acceleration. Since acceleration equals to velocity by time, so by the slope, by using the slope, we can get acceleration of the straight line, and by the area covered, the area which is covered by any rectangle or any triangle, we will get displacement. So let's see, and some cases are very much similar to that of displacement time graph. That is, if the straight line, okay, if the slope increases, it means the body is moving away, it means velocity is increasing. Okay, it means the body is moving away from starting journey, from the starting point. But if the slope decreases, isn't it? If the slope decreases or slope is negative, if the slope is negative, if slope is positive, it means if slope is positive, it means body is moving away. It is the same as displacement time graph, isn't it? If the slope is positive, the body is moving away from the starting point. If the slope is negative, the body is returning back to its initial point. So let's start. So first condition is if the body is in uniform velocity. Uniform velocity means velocity is not going to be changed with time. With time, velocity remains fixed. In 1 second, 10 meter. 2 seconds, it goes same distance, that is 10 t. Then in 2 seconds, it is 20. Again, next second, next, okay. Then it means this velocity is not going to be changed. Okay. Suppose a car is moving with 60 km per hour velocity, isn't it? So in first hour it is moving with 60 km per hour, second 60 km per hour, third 60 km per hour. Velocity is not going to be changed. So this, it has been shown through this diagram, isn't it? Again, as I said, that is time is always plotted along x-axis and velocity now it is taken along y-axis. Okay. So now 1, 2, 3, 4, the x-axis is divided into this 1 second, 2 second, 3 second and 4 second. C point indicates 4 second. Whereas along y-axis this is 1 meter, 2 meter, 3 meter, 4 meter. B is in meter. So you can see in 1 second velocity is okay. In first second velocity is 4 meter per second. Second instant 4 meter per second. 3 4 meter per second. 4 meter per second. It is mean it is moving with a constant velocity. Okay, fixed speed or fixed velocity. We can also call it velocity but time graph instead of okay speed time graph. Since as I said, in case of one-dimensional motion, it is straight line. Since direction is not changing, so distance, displacement, march becomes same, velocity, speed becomes same. So here you can see is not changing, same. So if we join all these lines, we will get a straight line AB just parallel to the time axis. Clear? So we can see it covers. So if we draw a rectangle OABC, it covers this area, isn't it? So if we get, so what is displacement? So now from the area of this rectangle we can get the displacement. Why? Because the area of the rectangle is, we know, that is length into breadth. So if its length means velocity, breadth means time. So velocity in time, you can see that is displacement. So that's why from the area of this rectangle covered by both velocity axis and the time axis is okay provides, from the area of this rectangle which is covered by both velocity and time axis, we will get displacement, that is OA into OC. This is 4 second, 4 into 4. So 4 into 4 equals to 16 meter. So the body will travel 16 meter. Okay. Now acceleration is 0. Why? Because acceleration means change in velocity. Change has to be there in velocity. If the velocity is changes means, if it's change means it may increase or decrease. If the velocity increases, then it is called acceleration, and if it decreases, it means retardation or deceleration. Clear? So since in this case velocity is not changing, so there is no change in velocity, so acceleration is 0. Clear? Comes to the second case. If the body moves with uniform uniform acceleration. Uniform acceleration means since acceleration equals to change in velocity, okay, instead of delta v, we should write small delta, isn't it? Small means changes, as I already told. So change in velocity by time. Since it is uniform, uniform means change in velocity has to be uniform. It means if velocity changes, has to be changed. But this change cannot be, isn't it, irregular, it is regular. It means velocity has to increase with a fixed quantity. It means 10 meter per second, 10 meter per second, 10 meter per second. Isn't it? It will be clear from the graph. Okay. So you can see in 1 second, its velocity is 10 meter per second. In second, it is 20 meter per second. Isn't it? 10, 20, 30, 40. I have not marked 20, 30, 40 because of the congestion. Isn't it? In 1, 2, 3, 4, 5 seconds, you can see time is plotted along x-axis, while is velocity along y-axis. The uniform acceleration. So you can see in 1 second the body having velocity 10 meter per second. 2, 20, in 3 seconds 30 meter per second, in 4 seconds 40 meter per second. It means you can see velocity is increasing at the rate of 10 meter per second at an interval of 10, isn't it? By a gap of 10 meter. 10, 20, 30, 40, 50. Very easy. So since velocity is increased at an equal time, okay, as an equal, with equal time of interval, with equal velocity, isn't it? Equal amount of velocity with equal time of interval. So as we can say that velocity is changing, increasing with a constant rate. So that's why it is uniform velocity. So as we can say, since here velocity is changing, so acceleration cannot be zero. So we can get both displacement and acceleration from this slope. So at first comes to the displacement, as we have seen. Now in the previous case, since the velocity time graph was a parallel, when the body was moving in uniform velocity, it covers the area which represents a rectangle, which was representing a rectangle. But here it is inclined to the time axis. So here represents the triangle. So here the figure represents the triangle. So the area of the triangle will give the displacement. Clear? So what is the area of the triangle OAB? You can see what is the area of the triangle. Now if we complete the rectangle, you can see it is just half, because this rectangle is consisting of two equal triangle, isn't it? So this triangle is half of the entire, isn't it? This triangle plus this triangle. Since the diagonal divides the entire rectangle into two triangles, so this triangle equals to half of the rectangle OYAB. So half into, so what is the area of a rectangle? Length into breadth. So length is AB and this is base. So that's why it has automatically comes. We all know the area of a triangle is half base into height. So AB equals to 50, OB equals to 5. So we get 125 meter. This is displacement. Now what is acceleration? When it is the ratio, velocity, okay, from displacement time graph, we get from the slope, we get velocity, displacement by time. So whenever it becomes, well, those quantities, displacement is generally obtained by multiplying velocity into time. So since multiplying by y and x axis, so it is the area of the rectangle, okay, or triangle. But since acceleration is velocity by time, so it obviously slope. As I already told, slope means tan theta is equal to perpendicular by base, isn't it? So AB by OB, that is V by T. This is AB by OB. So 50 divided by 5. So 10 meter per second square. Sorry, it will be 10 meter per second square. Since it is acceleration. Okay. Second comes twice. Clear? Now number 3. Now since it is that. Now since here the slope is positive. It means the body is moving away from its starting point. Okay. Now number 3. It is away. Now if it return back in uniform retardation. Uniform retardation means velocity is also changing, but in the form of decreasing, isn't it? 10 meter per second, 20 meter per second, 30 meter per second, 40, 50 meter per second. But now if it drops, if it decreases with the same rate, okay, change is also happening with the same magnitude, but here decreasing, isn't it? Time 1, 2, 3, 4 seconds, then 10, 20, 30, 40 seconds, isn't it? So it means if the body, clear, decreasing, velocity is decreasing. It means when a body is just, what can I say, just hit a wall and then it's return back, isn't it? Velocity is decreasing. Perfect example is when a train enters into a platform. Suppose it was moving with 50 km per hour, then it has to be stopped. So slowly by applying brake, it will have to decrease its velocity, then 40 km per hour, then 30, then 20, then 10, then 0, isn't it? I think you have understood clearly. So in this way, so it is decreasing. Okay, at 40, then 30, isn't it? At 0, 30, then 20, then 10, then 0. So at 4 seconds it completely comes to at rest, isn't it? So again it covers the area. If the area produces a triangle, so the displacement means area of the triangle OAB. Clear? So it is nothing but again half base into height, half base into height. So half into whatever, it is 40 into 4 or 4 into 47. So 80 meter. Now since it creates a slope, so obviously it will be slow, but since its velocity is decreasing, so as you all know that when velocity decreases, it is called negative acceleration, that is retardation or deceleration. So the slope of AB, but here in this case of negative, isn't it? 40 by 4 equals to 10 meter per second. 40, isn't it? Slope means 40, that is perpendicular by base, 40 by 4, 10 meter per second. Now one thing, if you write retardation, you cannot use negative sign, because retardation means negative. Or you can write, if you write acceleration equals to minus 10 meter per second square, then it will be correct. Then it is correct, because it is just like some people say in Hindi, apni to bad luck hi kharap hai. So bad luck means kharap luck. So how bad and kharap you cannot use, isn't it, to same meaning, isn't it, simultaneously. It is just like that. If you want to use, so if you write retardation, then you cannot use negative sign. If you use negative sign, then only in that case you can write acceleration is minus, isn't it? I think it is clear. Next topic is the next condition is, if body released from a height, what will happen? If we release a body from a certain height, what would happen? Initially it at rest, then its velocity will increase. Clear? Okay, concept should be clear. Release, its velocity will increase with a constant rate. It is g. G is constant. This is acceleration due to gravity is constant, but velocity increasing with a constant rate. That is 9.8 into 2 into 3, like this, isn't it? Plus. In first second 9.8, then again 9.8 plus 9.8, then again 9.8 into 2 into 3 in this way. Then as soon as we will hit the floor, for very momentarily it will become stop, then again it will just bounce back to the same height. If it is frictionless, body is absolutely in ideal condition. But generally, since it loses some energy after hitting the floor or any hard surface, its velocity generally decreases and it could not reach up to the same height. But here we assume the ball is very smooth, frictionless, the surface is also frictionless, it will return back to its same point. Let us assume. So in this case what happened? So since when we release the ball, its velocity increases, it represents by the straight line OB. This is time graph, this is velocity graph. So here the body is increasing. This represents the velocity, isn't it? It represents the increase in velocity. Clear? So moving away from the body. Clear? Velocity is increases because slope is positive. So now we will find out first the acceleration. Acceleration for AB means for the straight line AB. Slope of line AB, that is perpendicular by base. So this is 40 divided by 4. You can see 1, 2, 3, 4, and 40 by 4 is equal to 10 meter per second square. This is the acceleration. Clear? Now what is the retardation? What is the retardation here? After striking, then it will just bounce back, then it is decreasing, value is decreasing, isn't it? Minus 10, minus 20, minus 30, minus 40. So negative slope, that is minus slope of CD, means DC. So this is nothing, so this is base by hypotenuse, this is, isn't it? That is, this is theta, slope of line CD, isn't it? So this is this, okay. Slope of line CD, if we take this, isn't it? Slope this by this, or if you take this is this by this. Clear? Since it is DC in opposite, so we can take this. Clear? You can take this is minus slope of CD. Minus slope of CD means slope of DC. Clear, isn't it? So it means this by this. Clear? Since it takes in this direction, opposite. It is in this direction, it is in this direction, opposite direction. At first the body was moving in the downward direction, the next in the upward direction. Clear? So CE by, isn't it? That is CE. CE with respect to this angle, it's perpendicular. This is its base. So CE by DE. So minus 40 by minus 4 is equal to 10. since it is starting from 0. So 0, isn't it? So 0 minus 40. 0 minus 40 divided by minus 4. Since it is minus, isn't it? So minus or minus 40. Okay. This is generally comes here minus because of minus. Because of negative slope. Because of change in direction. So since it is opposite, it was 40 minus 0, but here it is 0 minus 40. Clear? So minus minus plus 10 meter per second. Again you can see this retardation come into plus. If you want to use minus, you will have to write down that acceleration minus 10 meters per second square. Now what is total distance? Total distance equals to, since from here hit the ground and then means total distance. It means it cover, this represents the upward motion, this is the downward motion, first case, and this is again the bounce back. It's bounce back journey after hitting the floor. So both the triangles simultaneously represent the distance. Since distance doesn't have any direction, so we will totally add, okay, without considering the sign. Clear? So the area of the triangle ABE plus area of the triangle CED, half into base into height, half into base into height, 4 into 40, 4 into 40, isn't it? How come it's 4, isn't it? 8 minus 4, that is 8 minus 4 is equal to 4. Here it is from 0 to 4, isn't it? From 0 to 4 completely 4, but in case of ED, 8 minus 4 comes 4. So total 160 meter. But what will be the displacement? Displacement will be 0. Why? Because the body generally returns back to its starting point, isn't it? Just like a circle, in case of circle, isn't it? Go and come back. So initial and final point, we all know that displacement is the distance between the starting point and the final point. Since it's meet at a point, so displacement is 0. Now the question is, so far we have seen distance and displacement is same, but in this case displacement and distance is different. Distance is 160 meter whereas displacement is 0. Why? Because you can see direction is changing. As I said, if the motion takes place in a straight line, then there is no curve. Distance depends on the path, whereas distance depends on the path, whereas displacement depends between initial and final point. Both are the same. In case of straight line arrow, there is no curve, no change in direction. But in this case, when the body was falling in the downward direction, its direction of motion is in the downward direction. When it comes back in the upward direction, so clearly direction changes. So that's why displacement and distance are not the same. Clear?